No. Are we going to do this moving forward? No. We needed this idea of the limit of the Riemann sum so we understand how we get to something else that is way easier, way easier. So we know now that the exact area is the limit as n approaches infinity from the sum of the areas of rectangles, base times height, from the first till the last, and we let n go to infinity. And this is the exact area. And we do have a different procedure. So this is exactly the same with. So I mentioned that this is the Greek letter sigma, or Greek letter S if you want, summation notation sigma. Because we are using this for, I guess, for different reasons. First of all, it's convenient and so on and so forth. But see, this is the Roman S. What if we stretch it? What if we stretch it? Okay, let's see how it looks. Stretched. From A to B. I'll tell you how we'd read it in a moment. From f of x dx. Exactly the same. How do we determine this? We don't know yet. I will explain, of course. But first of all, what is it? It's the same thing. The limit and the limit of the sum is basically in here. Dx or delta x, we know they are equal in measure. And of course, this is the function. So saying the limit of the summation or the limit of the Riemann sum or the definite integral from f of x from A to B, we mean the same thing. Yes, fine, but how do I calculate this? This is not easy for in many situations, except especially when the beginning of or the left or the the leftmost point of the interval is not 0. This is not easy to calculate. Furthermore, we are restricted to polynomial functions. But what if the function is sine x or tangent x or 1 over x? I won't be able to do this because I am restricted to those 4 formulas. So this has a much wider applicability than that. This is strictly for polynomial functions. I can't do anything else. Okay, how do I calculate the definite integral? How we calculate the definite integral is called the fundamental theorem of calculus, part 2. The fundamental theorem of calculus, part 2. What's about part 1? Yes, we'll get to that. I will not forget. It's an important part. But part 2, here is what part 2 says. That the definite, fixed, definite, between this and this, that's why you call it definite, from A to B, from f of x dx is, can anyone tell us what is the notation for f of x corresponding to f of x for the most general antiderivative?
Can you say that again?
Yes. If I'm given function f of x, what is the notation for the most general antiderivative?
Oh, capital F of x.
Very good. Then we draw a vertical bar or a vertical line from A to B. And then we do this. We evaluate this function at B first, at the top, the upper limit, minus when we evaluated at A. This is the fundamental theorem of calculus part 2. Very important, very, very important. F of x must be continuous on A comma B. If f of x is not continuous on A comma B, the theorem cannot be applied. Closed interval A comma B. If this function is not continuous on this interval, the whole thing fails. So I want to determine this using fundamental theorem of calculus and the notation called the definite integral. So I better get 3904. If not, I have to go back and check my answer and see what happened if I don't get 3904. So the area is the definite integral from 4 to 8. That's what we picked, from 4 to 8, from 4x to the third plus 2x plus 4 dx. Okay. 4. Which function prime is x to the third? Which function prime is x to the third?
X to the 4th over 4.
Thank you, and I'm happy for that. Plus 2. Which function prime is x?
X squared over 2.
Very good, and I'm happy for that too. Plus 4x. Put everything in parentheses. Vertical line, vertical bar from 4 to 8. Simplify it a little bit because it looks ugly. X to the fourth plus x squared plus 4x from 4 to 8. First, I plug in 8 everywhere. 8 to the fourth plus 64 plus 32 minus, please use parentheses, and plug in 4 everywhere. 4 to the fourth plus 16 plus 16. Uh, 8 to the fourth plus 64, so that's 96, minus 4 to the fourth minus 32. Oh. In one line, not in 3 pages. Page 1, page 2, page 3. And this is in, yes, I write big because I want you to see what I'm writing and it has to be clear, yada yada. But this will fit in 2 lines, not in 3 pages. We had to go through this first so you understand what the area, how the area was approximated at first before the definite integral. Any questions? Yes, we're going to practice a lot, the definite integral. Any questions on how we did this? Anyone? Any questions? So I would like to, before we look at properties, because the definite integral has a lot of properties, I would like us to practice. I'm gonna, I don't know if I'm logged out. I may be logged out already. I'm not logged out. Or am I? Am I logged out? Okay. I am not logged out by chance. We'll go to 5.2. Here they are. Okay, so we are past this. We already talked about the fundamental theorem of calculus. We want to practice from 27 through 34. 27 through 34. Let's choose.
32.
32.
Or we just did a quadratic trinomial. What about something else?
Yeah, we just want to practice one more, and then we'll go to more sophisticated examples.
Or 33 and 34 are also quadratic trinomials?
Yes. Let's just practice with one more.
Okay.
Anyone, so let's choose.
So 32 is fine.
Okay, so let's look at 32. And this is the integral from -1 to 2 from 4x squared plus x plus 2 dx. Do you want to work on this for a minute and see what we get? I also wanted to show you something with the graphing calculator. I'm not going to do it. Please don't do it just yet. 1 minute. Just let's just determine this by hand. But I wanted to show you in math, number 9. Here it is. -1 is the lower limit. 2 is the upper limit. And we have 4x squared. And we have plus x plus 2. And of course dx. It's silly that dx is not appearing and we have to put it in ourselves. So there is a way of determining the definite integrals with the calculator. Does anyone have an answer? Without the calculator.
I'm plugging in the 2 and the -1 now.
Do we have an answer for this?
Almost there.
The arithmetic, that's why I showed you how to calculate it, because the arithmetic, I don't want the arithmetic to slow us down. We are past arithmetic.
Oh, I thought you still wanted us to do it by hand.
Yes, yes, yes. I just want at least 1 or 2 to do it by hand, yes. It's cumbersome, right, to add and right. So that's what I meant. You are allowed to use the calculator on this.
I'm getting a fraction. I'm not sure
Yeah,
if
that's fine. So 36 over 3, I'm getting 12 plus 8. minus 1/2. So I got
Can't
20,
see what- You still have the calculator pinned to your screen.
40. Oh, yeah, sorry. I'm going to click enter. So 19.5, and you can change it into a fraction very easily. You don't have to do it. You can do it by hand. 39/2.
That's a different fraction.
And that's exactly what I got. So 40 minus 1. So let's go over this together. So I copy the 4, and then I have x cubed over 3. And then I have x squared over 2, and then I have 2x. Do we all have this?
No, I forgot the x.
Yes, so always, at least at the beginning, just ask yourself slowly, what function prime is x squared? What function prime is x? And what function prime is 2?
I have one question. So previously we were putting like plus c, but obviously
Very
we're no
good
longer-
question. I was expecting that. So here it is. So if I have the integral from a to b from f of x dx, this should be f of x plus c from a to b. Is that correct? Okay, here it is. We plug in b minus, we plug in a. F of b plus c minus f of a minus c. And we get f of b minus f of a. Very good. I was expecting this question because it makes sense. So the c is there. We omitted because when we distribute the negative sign in here and combine like terms, the c's cancel out. But yes, you're right, the c is there. Okay, so after that, when I plug in 2, I have 8 times 4, 32 over 3. I plug in 2, 4 over 2 is 2. I plug in 2, I get 4. Then minus. I plug in negative 1, and I get negative 4/3. I plug in negative 1, and I get 1/2. And I plug in negative 1, and I get negative 2. And then I have 32 over 3 with 6, and then I distribute negative 1 to 4/3, and then negative 1 to 1/2, and then negative 1 to negative 2. It happens that this is 36 over 3, which is 12. It happens that this is 8, and then minus 1/2. And then 20 minus 1/2 is 39/2. Is this okay?